Now let's learn how to draw these four structures with few dots and a line. So let's talk about circle, which you guys are familiar with. So how can we describe a circle with the help of a dot and a line? Think about it. Yes, we have a dot and then we have a fixed line. So these two are fixed and then a dot again. So let me summarize this. So this is fixed, a dot, this is a fixed line, and this will rotate 360 degree. So what happens? We get a circle. So that's how we can describe a circle. Now, in a similar manner, you guys have to think about how to describe a parabola. So I'll show you how to draw a parabola. You guys should think of the condition. Again, all of this will help you understand the concept better. So this is your parabola. I'll play it again. So this red dot and going across to this red dot is your parabola. Now you guys have to describe with just straight line and dot, applying some condition. So I'll give you guys another perspective. So if you guys want to think it's fun, if you guys feel it's fun, you can pause now because the next one will kind of give out the answer easily. Okay, I'm showing the next one. Take a second, have a look. I'll play it again. Have a look. So are you guys able to figure out the condition? Let me explain this. So we have to begin the discussion with two lines. So one on horizontal line and one a vertical line. And with a particular set of condition, actually, we need to pick up a point. Now, in this entire space, if I pick up any point, the distance from this point and the perpendicular distance to this line, they have to be equal. So here the condition are the following. So this is fixed, dot, this line is fixed line. So this is 90 degree. This, if I call it as, these two lengths has to be same. Again, all of this is needed when you guys are deriving. So you should learn this. Lengths are equal. Okay. So again, watch this video. It will help you guys to understand this better. Right. So that's your first point and that's your line which I spoke of. And between these two, we have all of this set of points which satisfy that condition. So this length is equal to this length. Right, again, this length is equal to this length. And this length is equal to this length. So any point of any space, any point, this condition is satisfied. Again, all of this is available in your note section and few other places will make it available. You guys can check it out. So there is one more variation that I'm not going to show you guys. Okay, you just can watch it. It's a flipped version. It has a different formula. That's why the video, we're going to make use of it. Next is your ellipse. Figure out the condition. I'll give you a clue. You guys have to watch this bar. And this bar is related to this lengths that we guys are seeing. Those lines. So let me show this at different points. So observe this and this. So what is happening? Let me explain this now. How do you draw an ellipse? So for this we need two lines which are again perpendicular, two straight lines. And then we will need how many points? Yes, 2 points which are equidistant from this particular point. Now if I happen to pick up any point on the ellipse, so the condition is the following. Let me, yeah. Okay, so I need to have one more point to discuss this actually. Maybe this, I guess. If I call this as say F1 and F2 and this is point A and this is point B, the condition is, can you guess? F1A plus F2A will be or should be equal to F1B plus F2B. That is the sum of the lengths should be equal. Okay, so here the condition is we have fixed lines. Actually, anyways, let it be. So those are your fixed lines. And we have this to be your fixed points. Fixed points. So with this condition, we'll be able to draw an ellipse. So I'll show the video again, I guess. Yeah, it's still available. Okay, it's done. The next one is your, and the last one is your hyperbola. It is similar to the last one. It's similar to ellipse, but there's another condition. Only the condition is different. Again, I'll show it. So what do we have over here? We have fixed points. We have fixed points. So those are your fixed points. Then any point on either of this loop. Say I'll take this and maybe different color. And say take this. See, they're part of your hyperbola. So if I happen to join these 2 points, these 2 lines, and if I happen to join this 2 and let us name them. So we have, say this is F1, that's F2, that's A, and this is B. So here we have F1A, the modulus of this F2A, right? The distance to the same point, the difference between this two, from this to focus, should be equal to F1B minus F2B, the modulus. The magnitude has to be equal, nothing to do with the signs. So that is your condition for hyperbola. It's very important for us because using this we're going to derive, and that's the end product, right? The algebraic equations. So for that we need to know this condition. Please pause and write all of this.